Okay, so now I'm going to take you through expanding the brackets or a distributive law, which includes single term multiplying a bracket. Not only that, but also a negative coefficient multiplying the bracket, and lastly a bracket multiplying a bracket, which we call binomial expansion. So maybe without wasting much of our precious time, just zoom in, and then we will refer to this as our example number 1, where let's say we have a single term, which is the one multiplying a bracket. So this is what we mean when we say a single term multiplying a bracket. Trust me when I say it is very, very easy, nothing complicated there. You just need to be aware that this multiplies that, and again it also multiplies that. Also, every time in mathematics when you have a letter, just know that the thing that comes first is the sign and then invisible 1. So that means the sign there is invisible positive and then the number is 1. That number is called coefficient. I hope by now you remember. So the 3, it will always multiply that 1. So a number will always multiply a number, and a letter will always multiply a letter. That's how it works. So that means 3 times 1, it is 3, and then you have your x there, minus what is 3 times 4? Definitely that is 12. And just like that, that is the end of it. Then now, okay, let's look at a negative coefficient multiplying at the bracket. So that would mean that was a positive coefficient multiplying the bracket. So here we can have negative 2 inside the brackets. Let's maybe have y, let's plus it by 7. So again, easy, that times that, that times that. You have invisible 1 there. Negative 2 times 1, definitely will be negative 2y, and then negative 2 times 7, trust me when I say it's negative or minus 14 there. Just be careful of the sign. What you should know is that same signs multiplying each other will always give you positive. If it's negative multiplying a negative, they will always give you positive. But if it is a positive multiplying a negative, they will always give you negative. So same signs multiplying each other will give you positive, and then different signs multiplying each other will give you a negative. It doesn't change. So maybe example number 3. Let's say we have 4 inside the brackets. It could be p minus 6. Doesn't really matter that much. What you know is that it is this by that, that by that. You end up having 4p, where we minus, what are we minusing there? 4 times 6, is it 24? 4 times 6, yes, it is 24. And that is the end of it. So let us now maybe look at example number 4, whereby you have negative, let's say inside the bracket you've got k, and then minus 9. So be careful here. The negative is never just a negative in mathematics. There must be something which is invisible there. In this case, it's 1. So it's like you are having that negative invisible 1 multiplying each of those. So you end up having negative 1k because it multiplies that invisible 1 there. And then again, negative times negative, positive. 1 times 9, it is 9. And that is the end of it. So it looks like in mathematics, a letter will multiply a letter, a number multiply a number, a letter multiplies a letter, and then the sign multiplies a sign. Yes, I actually wanted to say a sign will multiply a sign, number multiplies a number, letter multiplies a letter. They follow that format of sign multiplies sign first, number, number, letter, letter. So here it's like I'm saying that sign multiplied the sign of a positive there, and then that number 1 multiplies that number there, and then it ends there because we don't have another letter to multiply that k. That's why I had to write -1 and then k. I just write it as it is. Even with this one, it is the sign that gives positive sign, 1 and then 9 that gives that. That is the format that we follow when we work out math problems. Just never get confused, especially when it comes to the multiplication. So maybe let's now jump on to number 5. Not that much complicated. You just have your 5 inside the brackets. You have a, this is not 9 but it is a, that we minus it by, let's say, 3. So definitely you will end up having 5a minus 15. I think it should be a straightforward problem there. Maybe let's jump on to problem number 6. And then let's say we have negative 3 into, let's just say t, and then maybe let's plus it with 8. Okay, so now you have -3 multiplying that and also multiplying that. Nothing complicated there, honorable member. This is what you are therefore having. Then what will be that -3 multiplying the 8? It will definitely be -24. Yes. And that should be the end of it, because you no longer have the like terms that you can work out. So I hope that part makes sense. Maybe let me add, what is it? 3 or 2 more examples, and then I should be done on this topic. So let's maybe look at example number 7, where you have now a bracket multiplying a bracket. So let's say we have x that you plus it with 5, and then it doesn't end there. Let's say we have x where we minus 2. How are you going to work it out? Again, you just say this multiplies that, that multiplies that, and then once you're done, you'll say this multiplies that and that multiplies that. So you leave no stone unturned. Everything in this monomial, it multiplies each term on the other side. So x multiplying x, it will definitely be x squared. That's how you work it out when you multiply the same letters. Why x squared? Remember, the laws of exponent says if you are multiplying the same basis, what do? You add their exponents. The exponent there is invisible 1, then it means it would be x to the exponent of 1 plus 1, and that's why it ends up being x squared. But if someone is asking if it was different letters, then how would you work it out? You just write kt if the letters are not the same, because you can't add their exponents. Okay, I hope that part makes sense. So now you continue to say that x multiplies the -2, it will be -2x. Then you continue with the 5, multiplying the x, it becomes 5x, and then that 5 multiplies that -2, it will be -10. Do we have the like terms? It looks like, but this x squared, it doesn't have any other term which is the same as it, and then this one is a constant. Looks like this one is a number x, then you work out those. -2x plus 5x. How you punch it on a calculator? You can just say -2 banana plus 5 bananas. Yes, it will definitely give you 3 bananas, which is a positive. So if you say -2 plus 5, it will give you +3. And you can just minus that by that. That is the end of it. Okay, then it's fine. Let's try to another example, of which this example will be example number 8, where we have m, then you minus 4 there, and then you have m that you plus it with 3. Okay, then it's fine. Let's see. Here you therefore again have that multiplying that, and then you have that multiplying that. That's how you work it out. So that means you're going to have m squared, then you have plus 3m, and then what else do you have? You will have negative 4m minus 12, because it is negative 4 times that 3. Do you have the like terms? Yes, you do. M squared, it is 3 minus 4. It will give you negative 1. So you don't need to write the 1. It will be there as invisible 1. And this should be the end of it. I hope it makes sense. Remember, I may be explaining this to you now, but you just need to make sure that you redo this same thing that I've done until it makes sense before you jump onto the next one. So now let's do 2 more. Let's say you have q, and then we minus 7. You will therefore realize that any letter can be used. Any letter can be used. So now again you have this multiplying that, this multiplying that, you have this multiplying that, you have this multiplying that. Let's see. So what is q times q? Definitely it will be q squared. Then q times negative 1, it will be negative 1q. Then 7 multiplying that q, what will it be? It will be negative 7q. Then you've got that 7 multiplying 1, it will definitely be positive 7. Do you have the like terms? Yes, it looks like we do. Then these other ones, we write them as they are. This and that will be negative 8q. Just remember to write that 7 there, because it is part of that answer. And this should be the end of it. Maybe let's look at the last example, being example number 10, where now, okay, let's use letter R, just so that you can be aware that we just choose any letter from A up to Z, and then let's plus it by 2. Okay, what do you do? Same thing, just that by that, that by that, that by that, that by that. Definitely your teacher is going to teach you in different ways. They might be talking about the FOIL method and all of that, but at the end of the day, it comes down to that. And let's see, you've got now r squared, then that by that, it becomes 2r, that by that, it becomes 6r, that by that, it becomes 12. And then you've got obviously your r squared there, this plus that, it will definitely give you 8r. And then lastly, you've got 12 there, and that should be the end of it. So let me do this so that if necessary you can take a screenshot. Otherwise I will somehow have to make these notes available on the website. So let's see, the first one I did that by that, that by that, yes, that's fine. Number 2, that by that, yes. That by that, that by that, yes. That by that, that by that, yes. I'm just checking if I've done everything correctly and did not mix the signs. That by that, that, yes. That by that, that by that, that by that, positive, let's see, x squared. Negative 2, positive x, yes, that's fine. Then that by that, that by that, positive 3m, negative 4, yes. And then there, that by that, negative that, negative 1q, and 7q, yes, that's fine. Then r squared, this last one, it was just the positive. So it looks like it's easy when you have positives. Then when you have the positive and a negative, or negative and negative is something else. Okay, then it's fine.